Let us see the problem, how to reduce the quadratic form. Q is equal to 2x1 x2 plus 2x2 x3 plus 2x3 x1 into canonical form using orthogonal transformation. So the first step, you have to write down the matrix of the quadratic form. So the matrix of the quadratic form is A, and we know the first entry must be the coefficient of x1 square. Second entry is half into coefficient of x1, x2, and this is same as 1 by 2 into coefficient of x2, x1, and here it is coefficient of x2 square. Then 1 by 2 into coefficient of x1, x3. So this is same as 1 by 2 into coefficient of x3, x1, and this is 1 by 2 into coefficient of x2, x3, whereas this is also same as coefficient of x3, x2, and the diagonal is x3 square, coefficient of x3 square. So using this formula from the above given quadratic form, you can see there is no x1 square term, x2 square term, x3 square term. So all the diagonal elements are equal to 0. And coefficient of x1, x2, x2, x3, x3, x1, all are same. All the coefficients are same. They are equal to 2. So whenever we write here, we have to divide it by 2. So therefore, we are going to get all the entries to be same. 0, 1, 1, then 1, 0, 1, and then 1, 1, 0. So the eigenvalues, we can see, we know how to find out the eigenvalues. So write the characteristic equation. The characteristic equations are lambda cube minus s1 lambda square plus s2 lambda minus s3 is equal to 0. So we can able to find out what is s1. S1 is equal to the sum of the diagonal elements, which is equal to 0. S2 is equal to the sum of the minus of the diagonal element. So for entry 0, you will be getting 0, 1, 1, 0. And then for the second diagonal element 0, leaving the second row, second column, you will be getting 0, 1, 1, 0. Plus, and for the third diagonal element 0, leaving the third row, third column, you will be getting 0, 1, 1, 0. So cross multiplying this, you will be getting 0, minus 1, plus 0, minus 1, plus again 0, minus 1. And therefore, you will be getting minus 1, plus minus 1, plus minus 1. Therefore, S2 is equal to minus 3. Now, S3, we should find out the determinant. S3 is nothing but determinant A. So 0 into, therefore you will be getting 0 minus 1, and then minus 1 into 0 minus 1, then plus 1 into 1 minus 0. So first term will be 0, second term is 0 minus 1 is minus 1, therefore you will be getting plus 1. And here also 1 minus 0 is 1, so 1 plus 1 is equal to 2. So S1 is equal to 0, S2 is equal to minus 3, S3 is equal to 2. So therefore, you will be getting the characteristic equation lambda cube. S1 term is 0, then S2 is equal to minus 3 lambda, S3 is equal to minus 2, that is equal to 0. So lambda cube minus 3 lambda minus 2, lambda cube minus 3 lambda minus 2 is equal to 0. So this is the characteristic equation. Lambda cube minus 3 lambda minus 2 is equal to 0. Now solving this characteristic equation, you can able to find out the roots. The roots are nothing but the eigenvalues. Coefficient of lambda cube is 1, and then no lambda square term 0. Then lambda coefficient minus 3, constant is minus 2. So by trial and error, here also we go for a taking 1. Suppose if I take 1, 1 plus 0 will be 1, then 1, then 1, again 1 into 1, and then here we'll be getting minus 2. But when I multiply with minus 2 into 1 will become minus 2. So I won't be getting 0. So therefore, let us take minus 1. And therefore, here I'll be getting minus 1. So 0 minus 1 is minus 1. Minus 1 into minus 1 is a plus 1. So here it is minus 2. Then minus 2 into minus 1 is a plus 2. And therefore, the remainder is 0. So therefore, first root is lambda is equal to minus 1. The remaining roots are lambda square minus lambda minus 2 is equal to 0. So now we can able to factorize because the factors of 2 is equal to 2 into 1. But when you add this, you should get the middle term coefficient, the sum. The sum is what? Minus 1. So therefore, I should take a minus 2. So if I add this, I'll be getting lambda minus 2 and then lambda plus 1 is equal to 0. When I add, I'll be getting minus 1. When I multiply, I'll be getting minus 2. Therefore, my roots are lambda is equal to minus 1, comma minus 1, comma 2. So these are the eigenvalues. Next, I have to find out the eigenvectors. So to find the eigenvectors, eigenvectors you will be getting 3 cases. So we have to take lambda is equal to minus 1. So to find the eigenvectors, we know we have to solve this A minus lambda I on x is equal to 0. So therefore, when I find A minus lambda I, I'll be getting minus lambda 1, 1, and then 1 minus lambda 1, again 1, 1 minus lambda. So on x1, x2, x3, so this is equal to 0, 0, 0. So keep this as equation A. In the first case, let us take the different root. So if lambda is equal to 2, then the above equation. So substituting lambda is equal to 2 in the above equation, we'll be getting minus 2, 1, 1, then 1, minus 2, 1, 1, 1, minus 2 on x1, x2, x3 is equal to 0. So my equation will be minus 2x1, then plus x2 plus x3 is equal to 0. Then x1 minus 2x2 plus x3 is equal to 0. And then x1 plus x2 minus 2x3 is equal to 0. So solving the first and second equation by the method of cross multiplication. So solving 1 and 2 by cross multiplication method. So taking x1, x2, x3. So first I can take the coefficient from the first equation, take coefficient of x2 and then coefficient of x3, then minus 2 and then again x2 coefficient. Similarly, take from second equation. First I have to take a minus 2, then 1 and then again 1 and then minus 2. So this has to be cross multiplied. So that my equation cross multiplication method, I'll be getting x1 by 1, then minus of minus will become plus 2, and therefore the first term will be x1 by 3. And similarly, second term also x2 by 3. Third also x3 by 3. Therefore, x1 by 3 is equal to x2 by 3, and that is equal to x3 by 3. So dividing throughout by 3, I'll be getting x1 by 1 equal to x2 by 1, and that is equal to x3 by 1. So therefore, my first eigenvector is 1, 1, 1. So this is for case when I take lambda is equal to 2. Now case 2, if lambda is equal to minus 1, then the equation A becomes Substituting lambda is equal to 1, all the values are equal to 1 for me. So this is multiplied with x1, x2, x3 equal to 0. All my three equations will be one and the same. X1 plus x2 plus x3 is equal to 0. All the three equations will be same. X1 plus again x2 plus x3 is equal to 0. Third equation is also equal to x1 plus x2 plus x3 is equal to 0. So all the three equations represent x1 plus x2 plus x3 is equal to 0. Now put x1 is equal to 0. So therefore I will be getting x2 is equal to minus x3. So therefore x1 by x2 by 1 is equal to x3 by minus 1. So therefore my corresponding eigenvector x2 is equal to 0, 1, minus 1. Now in order to get the third eigenvector, let us assume x3 is equal to LMN. So as x3 is orthogonal to, this x3 is orthogonal to x1 and x2. Therefore, the why it is orthogonal? Because a given matrix is symmetric. So therefore, I can able to find out x1, x3 transpose. Okay, x1 transpose x3 is equal to 0. x2 transpose x3 is equal to 0. So 1, 1, 1. x3 is LM, n is equal to 0. Therefore, I'll be getting L plus M plus n is equal to 0. Then second equation is 0, 1, minus 1. L, M, n equal to 0. Therefore, I'll be getting 0 L plus M minus n is equal to 0. So again, by solving the two equations 4 and 5 by the method of cross multiplication, I'll be getting L by minus 2 is equal to M by 1 is equal to N by 1. And therefore, my third eigenvector x3 is equal to minus 2, then again 1, 1. Or I can write 2 minus 1 minus 1 just dividing throughout by minus 1. This is my third eigenvector. So I can able to find out eigenvalues. The eigenvalues are lambda is equal to 2 comma minus 1 comma minus 1. Corresponding eigenvector is x1 is equal to 1, 1, 1. Then x2 is equal to 0, 1, minus 1. And then x3 is equal to 2, minus 1, minus 1. Now next I have to find out the normalized model matrix. So normalized model matrix. So normalized model matrix can be denoted as P. So the first x1, if I take for x1, I have to write 1 divided by root of 1 square plus 1 square plus 1 square. Therefore, 1 by root 3. Again 1 by root 3. Again 1 by root 3. So L square plus M square plus N square, square root. And second column will be take x2. So 0 by root of 1 square plus 1 square. And therefore, you'll be getting root 2. Then 1 divided by root 2. Minus 1 divided by root 2. Then third eigenvector is taken to be in the third column. 2 divided by 2 square is 4. 1 square, 1 square. So therefore, I'll be getting root 6 minus 1 by root 6. Again minus 1 by root 6. So this is my P. Now the transpose is P transpose. So P transpose is the first column can be taken as first row. Second column 1 by root 2 minus 1 by root 2. Third column is taken as third row minus 1 by root 6, then minus 1 by root 6. So this is P transpose. Next step, we have to find out the diagonalization of the given matrix. So calculate D, and that D is equal to P transpose AP. So first we have to multiply AP, then we have to multiply with the P transpose. So therefore, your D will be equal to P transpose is 1 by root 3, 1 by root 3, then 1 by root 3, then 0, 1 by root 2, minus 1 by root 2, then 2 by root 6, minus 1 by root 6, minus 1 by root 6. And then the matrix A. The given matrix is 0, 1, 1, and then 1, 0, 1, then 1, 1, 0. Next, we have to write down P. So 1 by root 3, 0 by root 2, 2 by root 6. Again 1 by root 3, 1 by root 2, minus 1 by root 2. Then again 1 by root 3, minus 1 by root 2, minus 1 by root 6. So first you multiply the second and third term, then with the result you have to multiply with the first term. So the final result will be, you will be getting 2, 0, 0, 0, minus 1, 0, and then 0, 0, minus 1. So that is, we are getting D of the diagonal elements are nothing but the eigenvalues. So next you have to write in the canonical form. So the canonical form is y1, y2, y3, that is y transpose, and then D, y transpose, dy. This is canonical form. So D is 2, 0, 0, 0, minus 1, 0, 0, 0, minus 1, and then y is y1, y2, y3. So which is nothing but 2y1 square minus y2 square minus y3 square. So this is the way we have to convert it into canonical form with the help of the orthogonal transformation. So the orthogonal transformation helps us to find out the quadratic form to canonical form. I hope you all understood this. So we'll see the next problem in the next class.